All right, looks like it's time to get started. So thanks everyone for coming to this session. I'm Greg Kazanza. I'm a program manager on the VMM team. I've been on the VMM team for about 3.5 years now, working on various feature areas. The latest I've been working on for about the last 1.5 years is networking in VMM. So I worked all through the SP1 release and now on the R2 release on networking, trying to make it simpler and easier for all of you to consume. So there's still a lot of work ahead, but I think we're starting to make progress on that path. There's so much information to cover. We have 2 sessions, part 1 and 2. So as I said a few minutes ago, that we've got essentially 3 hours with a short break in the middle. So I know a lot of you have waited longer than that for a Surface. So I know you have the attention span to make it for the whole thing. So we'll see how it goes. The way we're going to break it down, essentially the first part is where I'm going to talk about how you set up your data center from scratch. So where do you start in VMM and get things up and running? What are the steps you go through to make sure that you can get networking working in VMM? Because really the hardest part is getting started, knowing how to get to that get through those first few steps. Along the way, I'm going to cover what's new in R2. There's a lot of things that we've changed and improved on. So I'll be covering that kind of intermixed throughout and trying to focus on that as much as possible. And then part 2, the real focus for part 2 is this hybrid networking scenario. The idea that you can take a network with network virtualization and span it from a hosted environment all the way to your on-premise data center. And through VMM, you can manage that whole process. So I'm really going to focus on network virtualization, what we're doing in the Windows Server Gateway, and exposing it all the way through to tenant self-service. So that's part 2. I hope all of you can stay for it. We'll take a break in between, but we've got a lot of information ahead. All right, so a quick recap of what we did in 2012 SP1. We really focused on breaking the features down into connectivity and capability. By connectivity, it's all about how do you expose your networks and establish the types of ways that different VMs can talk to each other. So you want to make sure that you can have multiple tenants in an environment and their VMs can't talk to each other, so they need to be isolated. You also want to make sure that these VMs can move about within your data center. So if you have multiple racks, multiple floors in your data center where you have different VLANs and different subnets, you want to make sure that the VMs can move across those different subnets without having to change their IP addresses. That's really where network virtualization comes into play and enables that capability. The other thing that network virtualization enables is the idea that you can bring your own IP subnet into another environment and basically extend your on-premises address space into a hosted environment. So we introduced this concept of a VM network. This VM network object is really what contains all of the settings for a network that a tenant will see and that they connect their VMs to. It's what defines the address space for network virtualization that's separate from the physical address space in the logical network. If you're familiar with VMM, you're well aware of what a logical network is at this point. And the VM network really abstracts that out in much the same way that a VM abstracts out the hardware from the physical machine for the virtual machine. Now, when we look at capability, a lot of work was done in Windows Server 2012 to enable a huge amount of configuration through software in the virtual switch. So the ability to control the quality of service, so the amount of bandwidth that each VM can use. Security, how many of you have had rogue DHCP servers come in your environment that you had to track down and figure out whose DHCP server that was? So now the Hyper-V virtual switch gives you the ability to control those. Has a DHCP guard, MAC guard, ARP guard that will protect things from like that from happening. There are optimizations and there are extensions that can now get installed in the virtual switch to give even more capabilities well beyond what the Windows team built into the core networking stack. And all of this needs to be able to be managed by a single point and consistently across your environment. So we introduced this concept of a logical switch, which is your central object that you use to manage all these settings that you need to make sure exist across your data center in a consistent way. So that you have the settings you expect everywhere in your data center. We also worked on our partner ecosystem to build the partners that are building extensions. So to make sure that we have extensions for the switch, to make sure we had gateways for network virtualization, to make sure we have the necessary optimized hardware. So we've been building our partner ecosystem. I'm going to talk about some new partner demos that I haven't shown before. If you went to a few other sessions, like CJ's SDN session just before this one, you've probably seen some of these demos, but I think I've got at least one new one that you haven't seen before. All right, so let's get into where do we start in VMM? Enough of the recap. So you're going to have lots of questions along the way to building your data center. We are going to start from scratch. You're going to have some cables coming into your data center. They probably won't look like this picture here, but you'll have a big bundle of cables that represent your connectivity to the outside world. What do you do first when you're setting up your virtualization environment? What are the decisions you're going to need to make as far as isolation? What type of isolation? Because you have many choices as far as what you're going to use. And how do you make sure it's consistent? Because you have to maintain consistency as your data center grows. Otherwise, you'll never be able to manage it reliably and easily. So I'm going to give you that information so that we can all together learn how to do that. And as I said, we'll learn all about R2 along the way. So what are the steps you go through in setting up your data center for virtualization? First thing, and what I think is the most important step, is planning and designing what your network's going to look like. You have to know what your logical networks are going to be even before you start to set up VMM. A lot of these subnets and VLANs can't really be changed once they're in use, because if you change it, then your VMs lose connectivity. You have to remap them, and it creates a huge problem to try to adjust after the fact. So you need to really plan ahead and understand what your networks are that you're going to need. Use Visio, use whatever tool you need, and that way you can plan ahead and understand what types of objects you're going to need to create in VMM. After you've done that, you need to start to take into consideration what kind of hardware are you going to have, especially when it comes to the optimizations in the network adapters. That puts some limitations on what you can do with your networks, where you can create your virtual switch, for example, and use a virtual switch, where you can use network virtualization. And if some of the constraints that are put on you by the hardware affect your design, you have to iterate back on that. So you're going to have to go back and forth until you finalize something that works with the hardware that you have, and the goal you ultimately want to achieve. Set up your hardware, and then you get to VMM. That's where you then start to create the objects in VMM. You create your logical networks is really where you start. Then you create your logical switches, and configure your hosts, create tenants, and then you're basically there and ready to run with it. So we're going to walk through these steps, starting with the design. What are the things you have to consider when you're setting up networking for VMM? So you're all generally going to start with some networks coming into your data center. You generally have a corporate network that'll be where your administrators will need to access VMM from and the rest of your data center. You'll have generally a network, could be the public internet, could also be your corp network where the actual users of your virtualization environment will come in from. These two may or may not be connected. It's really up to you. So ultimately, the corp network needs to be able to connect to VMM so you can manage it, you can run your admin console and connect to it. But all the management components generally have their own network that they use to talk to each other on the back end. You generally want to keep some isolation between your corporate environment and your data center management network, just because you don't necessarily want your average employee going and poking around all your Hyper-V hosts and your SQL servers and that sort of thing. So you do need to create some boundary between that. The other reason why you keep corp and your management network separate is because then you can define what your management address space looks like that's independent of your corporate address space, if you're running out of address spaces for your corporate network, for example. Your Hyper-V hosts, of course, need to be accessible from VMM, so you need to be able to connect to those, generally through this management network. They'll have additional networks because there are very specific quality of service requirements for things like clustering and storage and live migration. Your storage can very easily saturate the network. You need to make sure that it doesn't take away from the clustering heartbeat that needs to happen to make sure your clusters stay alive. So you'll have very specific requirements around that as well. And then, of course, ultimately, you're going to have tenants that come into your environment. They're going to need potentially their own isolated networks. This diagram doesn't call out any specific technologies yet for how you're going to isolate. That's one of the things you're going to have to consider is how are you going to isolate these tenants from each other. But they will need their own networks. And then ultimately, you're probably going to want to provide some sort of tenant self-service. We announced the Windows Azure Pack yesterday morning. It's essentially the evolution of the Windows Azure services for Windows Server Portal. And it's how we generally see tenants of these environments getting self-service. You can build your own portal if you want, since the Windows Azure Pack is built on top of SPF, Service Provider Foundation, if you don't like what we have in the box. So the first question you're going to have to deal with is, how do you provide the necessary isolation for this environment? You have two distinct kinds of networks. You have your data center networks that very rarely change. You set up your VLANs and subnets for management once, and then you don't change those, and, other than adding to them potentially if your environment grows. You're not going to go and rip out your management VLAN ever, or your management network. Your tenants, though, on the other hand, are very different. Your tenants are going to be coming and going as applications come and go. If you're a hoster of some sort or an internal IT that's hosting different departments in your IT organization, you're going to have different tenants that spin up applications, have specific security requirements. You need to have very specific networks for those that need to get created, and eventually they may get deleted again over time. So the life cycle of those networks is very different. So what do you have to consider then as far as how are you going to provide this isolation? There are four basic types of isolation up front that we'll talk about. Physical separation. It's probably the most secure. You have two completely separate networks. One often for tenants, one for your data center use, whether it's management or clustering, whatever. That gets really expensive really fast, very difficult to cable, so you can't really take that very far in your environment. But there still is a need really for, a lot of customers still do have very strict security requirements and need this physical separation. The most common way of isolating today is VLANs. I think all of you are probably familiar with how VLANs work. They're a layer 2 isolation mechanism. And essentially, the packets get tagged as they go out on the network. Whoops, too far ahead. A variation of regular VLANs is pVLAN. This is something we found is very popular since Windows Server 2012 introduced support for it. We've had a lot of feedback as far as how VMM supports it. We introduced some support for pVLANs. And then network virtualization is the new kid on the block. This is really the way that you can isolate, create isolated networks that are dynamic. Because they can come and go completely independent of what the actual fabric network is based on. It works by encapsulating the packets as they leave the Hyper-V host. They get sent on the wire using an encapsulated form until they get to their destination where they're unwrapped and the original address space of the tenant is exposed again. I'm going to talk about that in a lot more detail in a few minutes. VLANs, again, I think a lot of you, everyone in here knows what a VLAN is. And of course, you probably know the limitations of VLANs, right? You know that they're very difficult to configure on the switch. There's a limited number of them. And they generally, there's got to be a better way for a lot of these different types of networks. pVLANs work around some of the limitations of a VLAN. And there are essentially three modes that a computer that's connected to a pVLAN can operate in. You essentially have a primary and secondary pair, where on the primary, you have a promiscuous computer that basically can receive requests and send requests to basically any other computer in the primary-secondary pair. On the secondary side, though, however, you have all these computers that are either completely isolated from each other, they can't talk to anybody other than the computers on the promiscuous side, or you can have a community mode where you have computers that can talk to each other within the same community and to the primary VLAN, but they can't talk to any other pVLANs out there. In VMM, we support so Windows Server supports creation of all three of these types of machines as virtual machines. They have the support for it in the virtual switch, but VMM can only create isolated VMs, these isolated pVLANs. We don't support community, and we don't support creating promiscuous. You can create those through Hyper-V, and they can interact with the VMs that VMM creates. And you can even live migrate those VMs through VMM, and the settings are kept on the port. So those promiscuous and community VMs will still keep their settings. They live migrate. But if you, for example, store to the library or even do a quick migration, you may lose those settings if the port gets recreated for whatever reason, or if you disconnect or reconnect. So there is some limitation to what you can do with VMs you create through Hyper-V. Now, you can simulate community mode to some extent by using network virtualization on the back end. You create a row of essentially a set of isolated VMs using an isolated pVLAN. You add a second NIC to those VMs, and that second NIC is connected to a network virtualization network that you connect all the members of your, well, I'll call it a community, together so that they can talk to each other through this network virtualization network. Now, the advantage of PV-LANs is that you can get a great amount of isolation in your environment. So, for example, for a web server, that you want to make sure that if it gets compromised, it can't talk to anybody else without using a lot of VLANs. And then the other thing you get out of it is your address space gets shared among all of these machines in the PV-LANs. Whereas if you're using regular VLANs, you'd essentially have to have a subnet. You'd basically waste 4 addresses at a minimum for every subnet. All right, and then network virtualization, as I mentioned, it's the new way of isolating VMs. It's the way we think the future is going. And the idea is that you can create networks on the fly that are virtualized from what the actual physical network is using. So if your hosts are talking to each other and have the address space of 10.0.10 and 10.0.20, your VMs can have their own address spaces that are independent, and they can even overlap. You can have a production network that is on 192.168.10, and you can have a development network that you use for creating isolated tests without impacting your production network. Now, a virtual network, at some point, though, it's a little bit different than a VM. At some point, it has to connect to the outside world, and that's what the network virtualization gateway is for. That's what gives you this bridges the virtual world with the physical world. And so as packets come in from the outside world, where's my animation? Well, as packets come in from the outside world, the network virtualization gateway figures out, oh, there it goes, figures out where it's going to go. It encapsulates it so it can send it on the wire using the physical address space, and then removes the encapsulation when it arrives at the VMs. And then when the response goes out, it essentially does the reverse. So that's a key component. We'll be talking about that a lot in the next session, part 2. We'll really focus on these gateways. The last thing I want to talk about is no isolation. So this is essentially one other mode that we have that VM network can be created in. Basically says that any VM that connects to this no isolation VM network can connect directly to the logical network that's underneath it. The purpose for this is that you aren't tied to a specific VLAN or subnet at the time you create the VM. VMM will pick the right subnet and VLAN when you deploy it. So based on what our placement algorithm says, based on which rack it goes into on what host, we'll pick the right subnet and VLAN and then assign an address to the VM based off of that. It's used very much for a lot of your infrastructure networks. If you've upgraded from 2012 to SP1, you've probably noticed that your logical networks automatically get a VM network created for them because now VMs will only connect to VM networks. So we need to have a way for them to get, to make sure they still have their connectivity after an upgrade. And components like VMM, management components, need to be able to talk to hosts, which are directly on the physical network. So that's what these no isolation networks are for. So where should you use what? Where are each of these appropriate for use? Because there are a lot of different isolation methods out there. For infrastructure networks, the ones that don't change very often, there's a type of isolation for VMM called VLAN isolation. You can basically tie a VM network specific to a VLAN, and then any VM you connect to it will get that VLAN. That works great for infrastructure networks as long as your infrastructure stays small and doesn't grow beyond more than one VLAN, because then you have to have a separate VM network for that other VLAN. In that case, you want to use no isolation. That's what I'm going to demonstrate how to set it up using no isolation, because expect over time you're going to get more racks. You're going to outgrow the size of a single VLAN, and then you need to be able to still deploy VMs into either site. PV-LANs work great for load balancer networks or back-end networks where you need to have a private address space, but you want to have all the VMs behind that load balancer isolated from each other. And then also internet-facing workloads like web servers that if they get compromised, you don't want them to attack each other. And then we really think that network virtualization is ideal for tenant networks. You can use VLANs for tenant networks today. VMM supports the same type of VLAN network that you can use for the infrastructure networks. You can use that for your tenant networks as well, and essentially create a VM network that's assigned directly to a VLAN, and then give individual tenants access to that. So you can do VLANs for tenant networks, but we really see the future going towards network virtualization for that instead. Last thing I want to talk about in the planning is who defines the address spaces and how do you define it? Depending on which address space it is, your what you can use will come from a different source, and a different entity gets to define it. The main thing I want to point out is, your internet-facing addresses are very expensive and getting more expensive every day, your IPv4 addresses. So you need to make sure you use those as efficiently as possible. You obviously don't want to use those for your management network, for example. And then your tenant address spaces, those are defined by the tenant. Because if a tenant is coming into a hosted environment, they're going to be using the address space of their own data center and extending into that hosted environment. And if you are a tenant of a hoster, you need to consider that as you go to that hoster and you tell that hoster you want a hybrid network. You want to be able to define your own address space for that network in the hosted environment. The size of each network, the subnet size, of course, based on how many broadcasts. At some point, you're going to start to saturate your network with just broadcast traffic, so you generally need to keep these subnets relatively small. You also want to make sure you don't waste addresses. So you don't want to just do a /16 subnet for everything. And there are places where we generally support DHCP and static for logical networks, but there are places where static is required. In particular, when you're using network virtualization and when you're using a load balancer, you have to have static IP pools in VMM, so VMM can assign addresses from those pools. And then the last thing I want to say on this slide is that for IPv4 and IPv6, we generally support both in the same way everywhere in the product. So everywhere you see an IPv4 address, you can also use IPv6 address. The only thing is, in some places, you can't use both together at the same time. So for example, using network virtualization, the actual address space in that VM network, you have to choose between IPv4 or IPv6. You can't use both in those address spaces. So moving on to hardware consideration. So a little about different optimizations. SRIOV is an optimization that gives VM direct access to the network adapter. It essentially bypasses the virtual switch, so you get really high performance out of it, but with the trade-off that you're bypassing the virtual switch. So you lose all of the capabilities of the switch, including network virtualization, extensions, basically. So you lose a lot, basically, when you use SRIOV, but you do get huge performance. So workloads that really require it, this is where you'll want to use those databases or things like that require a lot of throughput. One key thing, though, you have to remember is when you create your virtual switch in VMM, that's when you have to enable SRIOV. You can't enable SRIOV after creating the virtual switch. But then you can choose which VMs connected to that switch use SRIOV. You don't have to use it even if the switch has it enabled. But you will, even if you enable it on the switch, you'll still lose some capabilities of the switch itself, such as bandwidth controls. RDMA is another technology that I want to call out. It's another optimization that's used for SMB3 traffic. So it really gives a fast way for Hyper-V hosts that are storing, especially if they're storing their VHDs on SMB3 shares. RDMA adapters give these hosts really fast access to those shares. The downside, of course, is that there is no teaming or virtual switch that you can use on top of these RDMA adapters. So you have to keep that in mind. If you have two RDMA adapters and you want to use RDMA, then all of your VM traffic on these hosts has to go through a different set of adapters, because those are the ones that will have the virtual switch. So when you are creating your Hyper-V host and you're teaming your adapters, there are essentially three models that you have to choose from. Historically, non-converge is what we've talked about for how you set up your Hyper-V host. The idea that you have an adapter that serves a single purpose. You have one set of adapters for cluster heartbeat. You have one for live migration. That way, the quality of service, you don't have to worry about storage, taking all of the, saturating the network and taking away from your cluster, for example. Now, that works fine for cheap 1 gig adapters. Kind of a cabling nightmare, but as you start to team, it gets more expensive, more cabling. And as 10 gig adapters start to become more prevalent, you don't want to devote a 10 gig adapter to your cluster heartbeat, because it's just a waste of that adapter. So instead, what we're seeing is that we're moving towards what we call a converged network. The idea that you can have a smaller set of NICs, but then you carve out these virtual NICs off of them for a specific purpose. And you assign the quality of service to those virtual NICs, either directly on the team or on a virtual NIC coming off of the virtual switch. When you bring RDMA into the picture, you kind of have to, unless you have 6 NICs in your Hyper-V host, which we're generally not seeing. We're generally seeing 4 NICs, 4 10 gig adapters. Then you have to create the virtual NICs on the virtual switch. The RDMA adapters are used for storage. You can send live migration traffic over them, and even potentially cluster, as long as you're very careful about making sure that clustering gets its right quality of service. But if you have to, you can even move clustering over to the virtual switch. As far as how to, going outside the host, what do you connect to? You want to make sure that your adapters, when they get teamed in the host, don't go to the same physical switch, because physical switches are known to fail. They're known to go bad, catch fire every once in a while. And you want to make sure that those are redundant, because those are probably the most common point of failure in a network. Those switches, generally the top-of-rack switches, we often refer to them as access switches internally. They connect up to aggregate switches, generally through a large set of uplinks, so that you have essentially what we call a flat network, so that if you access the network, if you have one VM that goes out to the network and needs to access a machine on a different rack that goes up to the aggregator switches and back down, you have enough bandwidth that you generally don't realize that you're going up to the aggregator switch and back down. It's how we're setting up our data centers internally at Microsoft, and it's kind of the trend we're seeing. So you get redundancy by having 2 switches everywhere, and you get high throughput and the ability to migrate your VMs anywhere by doing it this way. All right, so on to VMM. So how do you actually configure VMM now? You know what your networks need to look like. You know which logical networks you need. You'll need to have one for management. You'll need to have one for clustering. You'll need to have one for your external networks. And eventually, you're going to need to have some sort of network if you will be focusing on network virtualization. But you're going to need to have some networks for your tenants as well. So we're going to go through VMM and set that up. 2 basic objects of VMM you have to work with. The logical network. The logical network is really what models the physical network. VMM does not go out and configure switches, historically at least. We don't go out and set up routing, but we need to model it so we understand when we deploy a VM in a certain location, what address can we give it? And that's where a logical network comes into play. You're really just entering the network configuration that you've set up in your switches into VMM through a logical network and the sites that it contains. The logical switch is really the central place where we want to maintain consistency across your environment. This is really focused on how do we make sure that the virtual switches are consistent. So you have a central place where you define everything. We can then make sure that all your VMs that need a certain type of setting get the same settings. So we have consistent port profiles. We need to make sure that if you say you need an extension, it's consistently deployed on every host where that extension is needed. So we'll deploy the virtual switch extensions through the logical switch. And then over time, as your switch changes, as your logical switch changes, if you change the settings of a port profile on the switch, or if somebody goes to the Hyper-V host itself and starts tweaking things and changes settings that you didn't expect, we'll flag those changes as being non-compliant to what the logical switch expects to be on the host. And then you can go out and remediate it and repair it to bring it back in compliance. And that's how we maintain that consistency over time. So let's jump into my VMM environment and actually set up the logical networks. All right, so this is a VMM server that I have here. I basically am setting up a new environment for my TechEd data center. It has 1 host. It's very large. And I'm going to set up the networking for that data center. You can just ignore these networks. I have a few other hosts in other parts of my data center that have these networks in use, but we're really going to focus on this TechEd one as if it's all by itself. So the first thing I'm going to do is I'm going to create a management network. And if you're familiar with VMM SP1, you'll notice these options are a little different. We found that users were a little confused by the options we had before, so we streamlined it a little bit to try to give you a better explanation of what we mean when you select these options when you create your logical switch. So the idea of one connected network means that all of the VLANs and the subnets within that network can route to each other. It's what's needed for network virtualization, because you need to be able to move these VMs anywhere in your environment, and VMM will take care of making sure that they can all talk to each other. Then you can select if you want a VLAN-based network. So this is an isolated network where we don't make any assumptions that the VLANs within this logical network have routing between them. We treat them as independent networks. They may or may not have routing. VMM doesn't really care, but I still have that running. but you can you can create a VM network on top of each one of these VLANs. We really created that mode so that what we found was a lot of our customers were creating essentially a logical network per tenant, essentially, when they wanted per tenant isolation of their VLANs. And so by having these VLAN-based independent networks, we create a VM network on top of that in the same way. And of course, if you want PVLANs, you have a third option for PVLAN. So for management, we're just going to create one connected network. And this panel hasn't changed much in a few releases. It's going to be scoped to our TechEd Rack 1. It's going to be VLAN 0. And I'm going to leave the subnet blank because my management network has DHCP. And VMM doesn't actually need to know what subnet you're on. We only need to know what VLAN. VLAN 0 essentially means untagged. And so we're going to specify that, management rack 1. So I'm going to finish that. And then I'm also going to create a logical network for clustering. And again, this is going to be one connected network. And a site for that. Scope it to the TechEd rack. It's going to be VLAN 5. And here I'm going to actually give a subnet of 2.17.0.0/24. And if I'm going to have more than one rack, and these racks will have different VLANs and different subnets, then I just add another site for that. And later on, I'm going to actually assign specific sites to specific racks so that I can pull the right address from it. So this is going to be my rack 2. Oh, cluster 0 is rack 1. Oops. Capital's fine. Oh, now it's backwards. Rack 2. Scope it to my rack 2 host group. This will make sure I can't actually assign addresses from this to my rack 1. And I'm going to give it its VLAN and subnet. This is 6. Now, it's important, again, that this matches how I've configured my switches. I need to make sure that the switch has VLAN 5 and VLAN 6 enabled on it so that these clusters can talk to each other if necessary, or the machines on these different racks can talk to each other. OK, so I'll finish that. And then because this is using static IPs, I do need to create an IP pool. So I need to create one for each site. This is going to be a cluster 1. It's going to be cluster rack 1 IP pool, and I'm just going to use all the defaults for that. And the same thing for cluster site 2. In this case, I do need to select that it is site 2. OK, so now I have my 2 IP pools, one for each rack. The last thing I'm going to do is create, well, actually not the last thing, but the next thing I'm going to do is create an external network for the IP address that will be used to talk outside of my data center. So, if I'm a hoster, I would get a set of internet routable IP addresses. If I'm a private cloud or an internal IT hoster, then I would probably use my corporate address space here as well for this, for how these VMs are going to talk out. So I'm going to use again a connected network. Add the subnet. Let's go put to rack 1. So this is going to be VLAN 7. Now, if over time my environment grows and I need to add other additional VLANs, let's say this subnet I start to run out of addresses, I can just add additional subnets here as needed. OK, so now I've created my external, and last thing I do is create an IP pool here on that one. If I was really going to talk out of this, I would put the gateway in. So I'll put 9991. And I'd specify DNS if I wanted DNS also in that network. I'll just leave it blank for now. OK, and now let's say I want to use VLANs for tenant isolation, because you can do that. You don't have to use network virtualization. For that, I will create a VLAN-based independent network. So this can be my tenant VLANs. And this is going to be a VLAN-based network. And I create my sites in the same way, except I don't have to create a site per. I still create a site per rack, but I can put many VLANs within that rack. So tenant VLANs is for rack 1. The limitation here, though, of course, is now my tenants will be limited to this rack, of course, because that's where their VLAN is. One of the limitations of VLAN for isolation. This will be 100, and this tenant subnet will be 10.0.100.0/24. And I'll create 101. Okay, I'll just do 2 for now. I can add more later if I need it. And then the last thing I'm going to do is I'm going to create IP pools for each of these tenants. This is VLAN 100. Oops, I did 101. Now, you can script this through PowerShell so that you don't have to do this, especially if you have hundreds of these. But you can basically create a pool of VLANs for your tenants to use. VLAN 101. That's 101. I'm going to go ahead and finish that. So the last thing I'm going to do, before I can actually create a VM that uses one of these networks, is I have to actually create a VM network so that I can connect to it. I do that up in the VMs and services view. Go to VM networks, and I do create VM network. Now, for my management network, since I didn't enable network virtualization, my only option is no isolation. So it's basically a very simple wizard run through. So we just created the no isolation network for management. Same thing for clustering. So my clustering logical network. So VM network cluster. And then external. Finish that one. And then now I'm going to create a tenant VLAN. So this is going to be tenant 1. And this time I'm going to use the tenant VLANs network. But you'll notice this time, though, I actually have a slightly different set of settings. I can actually pick which VLAN I want to use and assign to this individual tenant. So at this point, I'm basically naming, basically giving a name to this VLAN so I know who's going to use it. If I don't care which VLAN this user gets, we can just select automatic, and we'll automatically assign to that user. But basically, I'm saying that tenant 1 gets VLAN 101, and this belongs to them. Now, after I create the network, this VM network, I can go back into the properties and set the access control to say actually which of my self-service users can have access to this tenant network. So I have complete control now over this VLAN, and basically say, here, you can use this VM network for VLAN 101, but you can't use any other VLANs, essentially. And that's all they can do is connect to this VLAN 101. So it really gives them the ability to have self-service control over their own VLANs. OK, and that's it for creating the logical networks now. These are ready to use, essentially. We'll talk, what you'll do for network virtualization is a little bit different. We'll talk about that later. So what's new in R2? What do we change as far as logical networks go? One thing that we started to do, and we learned a little bit about how virtual switch extensions, one of the things that we did with them is we made it so that they can start to populate these logical networks in VMM. So it's very easy to make mistakes doing what I was just doing. If I type in the wrong VLAN, type in the wrong subnet, and I won't really realize it until I create the VM and it can't talk anywhere. But what we found with forwarding extensions for networking in the virtual switch is that they can supply us with this information because they generally know what subnets and VLANs are out there because the network admin is sitting at the console of the, if it's a Nexus 1000V, they'll be sitting at the console, and have already entered that information in. So VMM just pulls it in from there. And what we realized is that, well, there are also these types of network manager tools that don't have switch extensions. So we broke up that API from the switch extensions and network management into 2 separate plugins. But at the same time, for a forwarding extension, you want to be able to implement both of those. We also realized that there may be devices that can serve multiple purposes. You may have a virtual switch extension that needs to get network virtualization policy. And we wanted to add additional types of devices and services that we could manage for networking. But we didn't want you to have to add each one of these individually. We wanted to make sure that you could have essentially add one device that it can tell us what kind of capabilities it supports. So we basically shifted our network plugin model from an individual type of specific function interface, for load balancers, virtual switch extension managers, gateways, and essentially say now everything is a network service. Well, everything with a little asterisk because we didn't actually put load balancers in there in this release. It's something that we'll get to eventually. It just didn't get there in this release. But every other type of plugin we have is now a network service. So instead of adding a gateway, you add a network service that is a gateway, or you add a network service that is a network manager. And they can, a specific network service can tell us that it does both if it wants to. At the same time, we started working with our cloud infrastructure team that's working very directly with a lot of switch vendors and really pushing standards-based management for network switches as a way for VMM to essentially give more ability to see how a switch is configured and really give the VMM admin a way to get more visibility into the connectivity of their network. So we also added in a plugin interface for physical switches so we can get some basic information from the switch, and I'll be talking about that in a minute. As far as network management goes, the primary driver behind splitting out network management from the switch extension is Microsoft IPAM. If you found in our SP1 release that script that we have for basically exchanging information with Microsoft IPAM, we're interested in being able to exchange information with IPAM, but the script that we had in SP1 is very limited. You had to actually run it manually or set up as a periodic task, and it really wasn't kept up to date that well. By having Microsoft IPAM as a network manager, we can report immediately when a network gets created to IPAM. The utilization we can report immediately. You basically add IPAM directly into VMM, and we'll start exchanging this information. At the same time, we can pull in networks from IPAM and go the other way. So your network admin can sit at Microsoft IPAM console, create all the address spaces and logical networks, and push it back the other way. So we're shipping in box with VMM a plugin for Microsoft IPAM. You just add your IPAM server, and we'll start exchanging information with it. Basically, how it works is network admin sits at IPAM, VMM admin sits at the VMM admin console. Network admin configures the basic address spaces, subnets, pools, and when the VMM admin adds it, all that gets pushed into VMM. The VMM admin then has to actually assign it to where they actually want those addresses to be used, because the VMM admin is the controller of the virtualization space. They're given these subnets and pools, but they're the ones that actually say where they're going to get used. Then over time, the utilization of these pools gets reported back. The network admin can track it, figure out when these pools are going to get starting to run out of space. They can add additional pools as needed proactively. And if the VMM admin decides to go and create their own subnet that conflicts with something else, network admin will get notified and can take the appropriate action. At the same time as tenants are coming in and creating their own address spaces, that information will get reported into IPAM as well. Notice IPAM isn't creating the address space, though, in this case. It is the tenant that's specifying their own. Generally, we see the tenants as being the ones that define their address space. And the same types of utilization stats get reported as well. If we look at physical switch management, and there's a whole session on IPAM. If you actually want to see that integration, go to that session. They're showing the VMM and IPAM integration, or listen to the recording if it's already happened. So going back to physical switch management. So the plugin model, so really what we wanted to be able to do is give the VMM admin a little more ability to see outside of their Hyper-V host, essentially. So one of the things that we do is when you add a physical switch to VMM, using an inbox plugin. So we have an inbox plugin that implements the physical switch interface. This inbox plugin talks using the standards-based network switch profile so that we can talk to any switch that implements this profile. In particular, the Arista line of switches is shipping this profile. So you can add an Arista switch directly to VMM, and VMM can start to discover which port that physical network adapter is connected to. We'll report back which switch it's connected to. And then we'll even start to do things like detect port compliance. So if you've defined a VLAN in VMM that's in use on that you say in VMM is in use on this host, and that port isn't configured for that VLAN, then we'll flag that port as being non-compliant and basically tell you in advance that, hey, this is going to be a problem. Now, if the account that you've added that switch has the ability to remediate, then you can actually, in VMM directly, remediate that problem if you've determined that the switch is actually should have that VLAN. And we'll actually go and enable the necessary VLAN and make other very basic port changes to that port. So it really gives the VMM admin one hop out of their Hyper-V hosts to be able to configure the switches without actually really knowing the details of the specific vendor's implementation. So Arista is the first vendor to be shipping it across the line. We're working with other vendors as well to bring that out. So you'll be able to basically add other switches as well. I'm going to show you a quick demo of that. There we go. With an Arista switch. Let me switch over to my other. Did any of you go to VJ's VMM overview session just before this one? OK, so a few of you have seen it, but that's good. Most of you haven't yet. OK. All right. So I'm going to start off this demo by just doing a ping. And you'll notice this VM can't actually talk anywhere. The ping's failing, destination host unreachable. So prior to R2, as a VMM admin or a virtualization admin, you could check the VM settings, see if it's on the VLAN you expect. You can check the Hyper-V host, see if it has the necessary settings, but really your knowledge ends there. If I actually go now, though, into R2 and see which host this VM is on, it's ARTest2. I see it's on fabinfra1. I'm going to go down to my network view for hosts. Oops. Scroll down. Click on the host pivot up here. And we have this compliance column that basically tells us whether or not parts of your network related to the host are in compliance. And you can see here this adapter is being flagged as non-compliant. It says network switch port is in access mode when it should be in trunk mode. We actually went out and talked to the switch to get that. You can see down here, if I scroll down, here is the Arista switch that I've added. I'm actually talking now directly to the top of rack switch. So I'm actually getting information from that switch to determine this compliance error. So go back to my host pivot. OK. So if I click it, I click remediate. So this will actually take, I don't know, about 30 seconds, because we actually go out and refresh the host as part of this to make sure all the settings are what we expect. I'm going to actually, let me move it over so we can see that VM running in the background. And I'm going to open up the properties of this, let's see here, host. Make a little more room here. So what it's doing now is it's using the network switch profile, the SIM-based standard method for talking to a switch and telling it to basically switch it from access to trunk. Some of the other information we get from that switch, though, is we scroll down to the actual adapter that's connected to the switch. You can see we have switch port details. We know the name of the switch. We know the port it's connected to. We know what mode it's in, the speed. Basically a variety of information about it. So now if this remediation doesn't fix it, which as you can see now, the ping started working, it did. But if it is something that's a little more involved, the VMM admin has the ability to go and tell the network admin, hey, this is where the problem is. I need to look at this port and figure out what's wrong with it. So we think that's going to help solve a lot of problems going forward. Quick question, yes? No, we'll set the VLANs based on what you expose through the network sites. So we'll expose the right VLANs as well. Yep. Oh, yeah. So the question that I just answered is, do we also set the VLANs, or do we just say all VLANs? So one more question. No, it's very limited as far as what you can actually set on the port. So specifically here, it's VLANs and establishing the connectivity. Really, any other settings, even if it's routes or any of the more advanced switch settings or router settings, we don't do yet. All right, let's switch back. All right, so moving on to the logical switch. Really the advantage of the logical switch is, I talked a lot about that. As part of creating the logical switch, we'll also create the teams. That we'll take 2 adapters or more, create a team out of those adapters, and attach them to the switch automatically as part of the logical switch creation, if you want that. I talked about a lot of the other benefits, how you have a single object, single place where you define everything. Really, the only reasons why you wouldn't use a logical switch these days, we really think everyone should, is that it is a little bit more work up front. If you're just setting up 1 or 2 Hyper-V hosts, you can get by fine without a logical switch. And the other thing that it does is your live migrations can only occur within the logical switch. The reason is that if you move from one switch to another, we can't guarantee that the port settings will maintain the connectivity during that move. So our placement limits where you can live migrate to keep it within the single logical switch. Generally, though, we expect that when you set up a logical switch, it'll span your entire data center so that that wouldn't be a limit. You're not limited to a cluster. You're just limited to where that logical switch goes. Basically, the way the logical switch works is you have the central object of the logical switch that has the central settings. When you create the virtual switch on the host, we take the settings from there to create the switch. Then we take different port profiles. We have a set for uplinks, and we have a set that are used for the actual VM connections. And that's really what defines the settings for connecting that virtual switch to whatever network adapter, whether it's physical or virtual. So in this example here, we took the management port profile and applied it to this switch for the uplink. And that tells us now that this physical adapter is the management adapter. At the same time, when you create VMs, then we'll take the port profile settings for each VM and apply those settings, the different settings for each NIC. You may need more bandwidth for certain VMs than others. And we'll apply those settings, and you repeat it on all your hosts in your environment, taking those same settings. Now, let's say at some point you decide that orange port profile actually needs different settings, right? It goes from orange to yellow now. We'll flag those being everything that's using that orange to be non-compliant, or actually it's brown, sorry. That brown to be non-compliant, and then you can remediate it, and we'll change those to match what was in the logical switch. So it's essentially how the logical switch works. The ways you get there, essentially you have 3 ways you can create your virtual switches on your host. Through bare metal deployment, you can actually add your host profile, what your switch settings should be, and we'll create the virtual switch using the logical switch settings as part of the bare metal deployment process. So you'll get a very consistent deployment of your host across your data center. If you already have your host deployed, your OS deployed, then you can go into your host properties, create the virtual switch, and say that you want to use a logical switch to create that virtual switch, much the same way as you would create a standard switch. Now, a standard switch is basically the equivalent of what you'd get if you created a switch through the Hyper-V manager. So if you go into Hyper-V manager, create your virtual switch, and then add that host to VMM or refresh the host into VMM, it'll show up in VMM as a standard switch, and you get your basic switch settings, but none of the advanced capabilities to use port profiles or any extensions. The last thing before I'll talk a little bit more about what we're doing. I'll talk about what we're doing with switches in R2, and also have a few partner demos as well, is the VM configuration. So you've got your switch set up. Now your VM, as I mentioned before, it's going to connect the VM network to is what you're going to connect to your VMs now. But the other thing that you have, and that gives you the connectivity, but the capability, actual settings that are going to get applied that come from that port profile on the logical switch, those come from what we call a port classification. This is essentially a container for profile settings. So you put port profiles into this classification on each switch. And then when you create your templates, you refer to the classification. And then wherever you deploy, even if it's to different logical switches, we'll pull the appropriate port profiles based on what that switch says should be used for this classification. It's very similar to what we do for storage classifications. It's basically a global name for your port profiles, and it's not tied to a specific switch configuration. It's also what tenants get to see, because you don't want to show the tenants that you're using a specific extension or specific settings behind that. You just give them the classification, and that's all they get to see. So it separates and creates an extra layer between your fabric and the tenants. So let's jump in back to my demo environment, actually create a logical switch real quick. Sure, I'm on my right server. Okay, so this is where we left off. We created our logical network. So we're going to go back to our fabric view, and we're going to create our logical switch now. The first thing you need to do to create a logical switch is you need to create a port profile for uplinks. You'll notice if you looked at SP1 and now in R2 that we've made the terminology a little more consistent. Before we had native port profiles, we had extension port profiles, native extension uplink port profile. No, extension uplink native port. Well, it was very confusing. So now everything is just a port profile, but there are just certain properties that define what it is. So you have uplinks that are virtual. You have port profiles that are virtual, port profiles that are uplink, and then you also have what it applies to, whether it's going to apply to Hyper-V, and that'll set the Hyper-V settings, or if it comes from a specific extension, it'll tell us that this port profile came from an extension. So I'm going to define a new uplink for my TechEd data center that I'm setting up. I'm going to create a Hyper-V port profile. I'll call this my TechEd uplink. Now, before I switch to uplink, I'm just going to show you the virtual settings real quick, so you can see the number of settings. These are all the basic Hyper-V port settings we have available that you can put in a virtual port profile. One new setting that we've added is this ability to use guest-specified IP addresses for network virtualization. If you're familiar with network virtualization from SP1 and Windows Server 2012, VMM had to assign the addresses. Now a VM can specify its own address, and by doing that, we can enable the ability to have guest clusters using network virtualization. I'm just going to go back now and say that this is actually an uplink profile. Another thing that's new in R2 is the dynamic teaming mode for teaming. The Windows Server team, the core networking team have done a lot of work to basically make teaming work even better to make sure that the necessary spread takes place. So in Windows Server 2012 R2, there's a new mode called Dynamic that makes sure that the spread does happen more efficiently. Of course, Dynamic's not available for Windows Server 2012, so if you select Dynamic in your port profile, this port profile can only be used on an R2 host. So to make a port profile that's a little more generic, we added in this new option called Host Default. Basically what that says is, if you deploy to 2012, we'll use basically the default settings for 2012, which, if I recall, was, I believe, Hyper-V port, but don't quote me on that. But if you deploy to an R2 host, we'll set it dynamic by default, because we think that dynamic is the right way to go for everyone. So I'm going to leave it as host default so I can use this port profile anywhere. And then I'm going to say which network sites that I just defined are available on this port profile. So since this port profile is going to be used on rack 1, it's going to use my clustering rack 1 site, my management rack 1, my tenant VLANs rack 1. So basically what I'm doing now is I'm telling VMM wherever this port profile gets used, these are the networks that are available on that network adapter. If I add more networks over time, then I only add it to this one port profile, and it'll automatically get applied to every host. If you used VMM 2012 before SP1, you'll know that you had to go and do that individually on each adapter. So now you have a consistent place to do that. One other thing that's different, if you're using network virtualization in 2012, you had to actually check this box off to enable the Hyper-V network virtualization filter. With Windows Server 2012 R2, the filter is moved into the virtual switch, so now you don't need to enable it anymore. It's just always available. So it doesn't hurt to check it off. We'll enable it if you use this on a 2012 host. We'll just ignore it if it's on an R2 host. OK, so I finished the port profile. And now I'm going to create my logical switch from that port profile. So this hasn't really changed much. Actually, it hasn't changed at all in R2. So I'm just going to do this quickly. Good switch. Here's where you would enable SRIOV. I'm not going to use any extensions. I'm just going to add this one port profile that I've created. It's my new one, my TechEd uplink. And I'm going to say that teaming is allowed on this switch. And then I'm going to add some virtual port profiles. Again, this is where I specify my classifications. So I'm going to have one for host management. We have a few of these available out of the box. You have to map the classification to the port profile, though, if you want to use them. I'm going to add management. I'm going to add clustering. Cluster. And I'm just going to add a medium bandwidth for regular VM use. And then I'm going to set this one as the default. The default just means that if a template, it's not required to specify a classification, because if you want a template that can get deployed to a Xen server host or a VMware host, or even a Windows Server 2008 R2 host, that doesn't support any of these advanced switch settings, you're going to be able to create a template with no classification. But you still want to be able to deploy that template onto a 2012 host with a logical switch. This just says if you do that, deploy a template with no classification, these are the settings that you're going to get on that host. OK, so I'm going to finish. You can add your virtual port profiles later. You don't have to actually add any up front unless you actually want to create vNICs with it. All right, so the last thing I have to do is actually now create a virtual switch on a host that uses this logical switch. So I'm just going to go back to my host now and go to the host properties. And I have 3 adapters in here. So I'm going to do new logical switch. I'm going to use my TechEd switch. I'm going to select my 2 adapters using the uplink that I just created. I'm actually going to put 2 adapters on here. So by putting 2 adapters on here, I'm basically telling VMM to automatically team the adapters and apply the teaming settings from that port profile. It's very easy. It's one step to create the team. I can also create virtual adapters on this switch as well. And if this is the only way for me to talk to this host through these 2 adapters, then it's very important that I actually create this management adapter, AGMENT, and check this box off. Because what this box will do is it'll say, copy the settings from the physical adapter, or the first physical adapter in the team, to this virtual adapter. And so that way, if you're using DHCP, you'll get the same IP address for this host, and your DNS doesn't need to be updated. I still need to select the VM network. And then I'm going to add one more for clustering. This is on the cluster VM network, and I'm going to use my cluster port profile to make sure I get the right clustering settings and the right quality of service for clustering. So hit OK. This is going to go out, gives me a warning just saying that if I do, it's the only way to talk to it, I need my management adapter. And that's going to go out, and that's going to go and create this virtual switch on the host, and it'll be ready to use. Next thing I want to talk about is, I mentioned all these types of isolations. There's actually one more type. And if you are using a forwarding extension, your virtual switch, you have the ability to do external isolation. A forwarding extension can actually implement its own isolation. VMM doesn't care what technology is used. The switch itself can basically say, I want to create an isolated network. It's opaque to VMM. An example of that I'm going to show right now is the integration with the SCVMM and NEC programmable flow switch extension. And basically what this extension does is it lets you in the NEC OpenFlow controller, it lets you basically create a virtual tenant network there that gets used by VMM. And you basically create a VM network for these virtual tenant networks that you create in the programmable flow controller. And this will be shipping this year by NEC. So let me jump into the demo of this real quick. Just need to reconnect to the demo environment. OK, log in. So this is a demo environment provided by NEC. Basically, what I'm going to do is I'm going to create a virtual tenant network in the programmable flow controller. And Control 1. So you can see here, it's a little difficult to read, but I'm basically registering a VTN, a virtual tenant network, on VLAN 403. So I created that tenant network, and now I'm going to go into VMM and actually create a VM network that uses it. If you look at VMM here, you can see that I have the PF1000 VSEM added. I have the NEC plugin. And I'm going to go, and I have a virtual switch, or a logical switch, that already has that extension enabled. So I've already deployed it to my host simply by going to extensions, checking off the box for that extension. If you look, we also did import uplink port profiles from the extension, also the virtual port profiles as well. So if I actually go to add, you can see we can get port profiles and get port settings from the PF1000. So I'm going to cancel out of that. And I'm going to go create a VM network. So this is my demo 1 VM network. And I'm using the logical network that I imported from the NEC extension. I'm going to say this is a user-defined network. Demo 1. And the subnet. And what this is going to do, this is going to go out through the plugin model and tell the NEC extension, okay, realize this VM network and assign it to the demo1 VTN that we created. So we've now created the network. The last thing I need to do now is, where did that go? Is actually add an IP pool to it. So here's demo1. I'm going to create an IP pool so that we can actually assign addresses from it. Okay. And then I've actually already got a VM that I've created that I'm just going to attach to. You can see I'm already doing a ping. I've already got static IPs assigned to it, but there's no connectivity for this VM. So I'm going to now actually connect it to this network that I just created. So I'm going to go back up to my VMs and services and connect that VM to it. I'm going to connect it to the demo1 network. I'm going to run. I'm going to do test 2 as well, because I need to have another VM that the one that I'm pinging. And if everything works, you can see the ping started going. So I have actually established connectivity between these two VMs using the virtual tenant network that I created in NEC. I can actually go into the NEC PF view and actually show this demo1 network and actually show the flow on the topology map. And if I click on the right, see if I can get that to show up. Wait, actually I need the correct one of these. Find the right view. Oh, there it is, that one there. So you can see these two VMs are talking to each other, and it's fully reflected in the PF1000 console. So that just gives you another example of switch extensibility and the integration with VMM that'll be shipping this year. There are representatives from NEC here. If any of you want to talk to them afterward, if you have questions, they'll be happy to answer it. So as we look at what we're doing with forwarding extensions in R2, there were some limitations to what was introduced in R2. In particular, network virtualization and forwarding extensions were a little bit like oil and water. They just didn't work together, which means that you couldn't use network virtualization with this NEC extension or the Nexus 1000V extension. So what we want to do is, working with the Windows Server team, we want to make sure that we could enable network virtualization packets to go through the same switch where a forwarding extension works. So you have to remember these forwarding extensions, they don't replace the switch functionality. They're just meant to basically extend it. So we did the additional work with the Windows networking team to enable this in R2. At the same time, we also enabled these extensions to basically implement their own network virtualization at the same time. They can utilize the same logical networks that we use for Hyper-V network virtualization to build their own virtualization, such as VXLAN. So if you look at what we did and how our object model, in VMM we had to make some changes to how our object model was built in SP1. A virtual switch extension manager could only supply these not connected logical networks. They could supply us with the network sites, and then the VM networks got created and tied one-to-one to a network site. In SP1, essentially we're getting rid of these special logical networks that only contained the externally supplied objects, and now we're basically saying an extension manager, which is actually now a network manager, can supply any type of logical network, connected or not connected, and they can basically supply their network sites into either of these logical networks. So in that way, the extension can now consume these connected logical networks and be aware that there are network virtualization packets going through it. And at the same time, external VM networks can be created on not just not connected networks, but also connected networks. And by doing that, now these extensions can implement their own network virtualization. And so what I'm going to demo now is a really early prototype of the Nexus 1000V with traffic going through, with network virtualization traffic going through and native VLAN traffic going through the Nexus 1000V extension. One other thing I want to call out is the Nexus 1000V is now available for download for SP1 and Windows Server 2012 as of today. They made it available. So if any of you are interested in that. All right, so I need to switch over to my, I've got another demo environment for that. OK. So in this environment, I essentially have 2 hosts. Let's see. Screen got a little shrunk down. And I have a Nexus 1000V forwarding extension added. If I go to my logical switch right in front of me, I have my Nexus 1000V switch, and I have the Nexus 1000V extension enabled. If I go up to my logical networks, you can see I have a logical network that came from the Nexus 1000V for network virtualization, and then also one that's dedicated to essentially VLANs. And both are going through the same Hyper-V host and are both added to the same logical switch. So if I actually go to one of these hosts in my infrastructure up here, I can see that I have 2 hosts, and I can actually go to the Hyper-V manager. I can see that on this R710 host, I'm doing it through Hyper-V manager just to prove that it's real. There's only one switch, and it does have the Nexus 1000V enabled on it. I can actually go to the VMs and start sending some traffic through. So what I'm going to do is I'm going to my native VM. So this VM is connected to a VM network that's set up for native VLAN traffic. And I'm just going to start copying some files. So what this is doing is just copying a large VHD across from one VM to another. And if you look, you can see I have some counters on the NVGRE packets that are going through the switch. So this would tell me basically if there was network virtualization traffic. And you may see a packet now and then go through, but there's very little actual traffic going through this switch using network virtualization. But if I actually look at the monitor of what's actually being sent through the actual virtual network adapters, you can see there's actually a huge amount of traffic going through these adapters right now. So there is traffic going through on the native VLAN being forwarded by the Nexus 1000V. If I actually go over to now another VM that's connected to a Hyper-V network virtualization network and do the same file copy from one VM to another, you can see now that I do have traffic going through the VNICs, and you see the counters now are actually increasing rather rapidly. So you can see now there's actually traffic going side by side with network virtualization and regular VLANs going through the same Nexus 1000V forwarding extension. So with that, I'll wind up this part 1 session. Basically, I want to make sure you plan everything ahead of time. Get your networks well established that you know what you need to create. I told you what's new in R2. And we improved on our forwarding extension integration. So you should expect demos like this from all of our vendors in the future. And then a reminder, what we'll be covering in about 30 minutes from now in the same room is basically how to use network virtualization, basically in the same type of environment that I just created, basically with VLANs. How do you bring network virtualization in, configure your gateway, and get it all set up so that you can use it? And I've got Charlie Wen from the Windows Core Networking team is going to come in and also talk a little bit about the internals of how the gateway is going to work. So I'll be here for questions. I hope you can all come back in 30 minutes and learn some more. So thanks.